Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to part 7 for our Pixel Platformer series. This series was made possible by all of the people who support me and my channel by purchasing my Godot course. It's currently on sale, and there's a link in the description and in the comment section if you're interested in picking that up. In this video, we're going to we've got our spikes here that can damage the player, but our enemy can't damage the player. And we need to set up a system to make it easy to add a damaging element, I guess, to a new enemy that we add to the game. We don't want to have to rewrite that code or redo all the logic every single time we add a new enemy or any type of object that can hit our player. And so I like to use a component for this. Now, Godot doesn't strictly use components in the same way that an entity component system might, or it's kind of similar to Unity in the way that it uses components. But ideally, what we're going to do is create our own scene that we can attach to any object or enemy that needs to be able to damage the player. So we're going to create a new scene, and we're going to make it an area 2D because this needs to detect overlap, right? And in fact, we can open up our spikes and we can see that they are in area 2D, right? And we can come in and we can actually look at their code here. We've got on spikes. We're gonna use the same exact code, only be aware that this is connected via the editor to our body entered signal. So right here, that's what this little icon means. If we were to just copy this code over, it wouldn't work the same. So we're gonna call this a hitbox, and we're just gonna save this scene. And now we can add a script to it. And we can, once again, connect our body entered signal. So we're selected hitbox. We're on node and signals. We can connect the body entered signal and connect. And now we have that code. And you can see that it has this little green icon, meaning it is connected. Now you can connect signals manually, or you can connect signals in code instead of doing it in the editor. But we're just going to do it in the editor for now because it's a lot easier for beginners to kind of follow. So now we're going to copy this code right here from our spikes and paste it right here into our hitbox body entered. So now each time our hitbox overlaps with the player, it will reload the scene. And we can save. And now we can actually come into our spikes. And this is the funny thing, our spikes don't need to be in area 2D anymore. So we're actually going to grab our spikes here, our spike scene. We're going to go to node signals and make sure you're on your spikes and not on hitbox. We're going to click this right here and we're going to click disconnect. So now we've disconnected that signal. And if you click on your spikes script, you'll see that green icon is no longer there. So now we can actually click on spikes, go to inspector, and we can actually remove the script completely from our spikes. We just press this little button right here. And that removes the script. We can save. We can come down and find our spikes script, and we can right click on it, spikes.gd. Make sure you don't right click on spikes.tscn, that's your scene. Spikes.gd, right click and delete. And remove it from the game. We can remove our collision. Well, actually, let's if you removed it, that's fine, but we don't actually have to remove this. Now we're gonna right click on our spikes root node here. We're gonna do change type, and we're just gonna make it a node 2D. It doesn't have to be an area anymore because it's not going to be used to detect overlap. And now we can save, and our spikes, they have this collision polygon attached to them, but there's no way for them to determine whether or not they're actually overlapping something, and you can see we're getting a warning here, a configuration warning, because it's not part of an area 2D or some other body, physics body. Okay, so however, now that we have our hitbox and the code is inside of here, we're actually going to leave this configuration warning right here and just close out of our hitbox. And we're going to come to spikes, and we're going to click on the root node and instance a hitbox on it. And we can drag our collision shape node onto this hitbox. So now we no longer have a configuration warning, and this also doesn't have one. And our spikes here, our hitbox here, we'll want to check to make sure it's targeting the proper layer. So come to collisions. You can see it's on layer world and it's targeting layer world. We actually want to turn off both of those. Okay. We want our hitbox, in fact, what we need to do is do this inside of the hitbox scene. So we're going to click on this little icon here, little scene icon. And inside of our hitbox scene, we're going to come into collision and make sure that it's targeting characters. So layer is none. It doesn't need to be on any layer. And it's targeting characters. So now this hitbox will by default target characters, and come into your hitbox here, and you can see this little icon over here. This means that the configuration of this scene right here is different from the configuration of its scene that we inherited from, or that we instanced from. And if we click this, it will reset it. So now you can see that our hitbox inside of our spikes is correctly targeting the characters layer. Okay, now if this doesn't work, it's probably because if it doesn't reset when you land on the spikes, the first thing you'll want to check, and I've seen this happen a lot, okay, so that's why I'm bringing this up. You want to check to make sure that the hitbox is targeting the proper mask and that your player is on the proper layer. The player layer right here. Okay, that's the first thing you'll check. Now the next thing you'll check is you'll go into your hitbox scene and you'll click on the script and you'll make sure that this little icon is here. Because if this icon isn't showing up, then that means your signal actually isn't connected, and you need to click on your hitbox, go to node, and connect the body entered signal. Okay, so those are the first two things to check if you're having issues, but hopefully it worked great for you. Now we can come into our walking enemy, right? And our walking enemy, it's gonna need its own hitbox. So we're gonna click on it, the root node, we're gonna click instance, and we're gonna do a hitbox. Now we need to attach some, we've got a configuration warning, so we need to attach some collision shapes here. And we're gonna do, for this, I think a polygon would be good as well. So make sure you have, I have grid snap turned off, but I have pixel snap turned on. I'm gonna click this little plus icon. And I'm gonna do a very similar let's do this. I'm going to do a pretty similar shape to what we're going to give some extra. We'll ignore the outline on the enemy and just kind of get that shape right there. Okay. Now our enemy hitbox has its own collision polygon. Now you might be tempted to have your hitbox have a collision polygon or a collision shape automatically attached to it, and then whenever you instance it, you just edit that over here. And the danger with that is that resources are shared. And so your spikes, the resources that you have inside, although I'm not sure if a collision polygon uses, if a polygon is actually, since it's just a pool vector 2 array, it might not actually be a resource. So that might actually work if you have a collision polygon attached to it. But every time you instance a hitbox, you'd also have to right click and do editable children in order to see that anyways. So, you know, I think this is the best way to go. But let's say you did use a collision shape instead of a collision polygon, right? Collision shape. And this collision shape was actually attached to the hitbox scene. So every time you instanced it, you would get a new scene. Well, it would have its own collision shape, and that shape would be shared. And so every single time you modified this shape, it would modify it for every single scene that has that hitbox. And that gets a little complicated, but just know that by default, resources are shared. And sometimes, 99% of the time, that's great because it means less processing for your computer to deal with. It can kind of stamp that resource around and not have to redo it every single time. But there are a few cases where it can be frustrating, so watch out for those. Now our enemy can damage us. You can see if we touch the enemy, it sends us back. It feels like it needs to be, it's pretty lenient on how close we can get without getting hit. I would actually maybe make it just a little bit less lenient if we click on this and come out just a bit more. This is up to you, but man, that was, you can really get close to the enemy. That feels a little better at least. You can still get close, but you're probably going to get hit if you get too close. Okay, so now we have the same hurtbox and the same hitbox, or the same the same hitboxes set up for both of our enemies. And if we want to add any other element into our game, we can simply attach a hurtbox or a hitbox scene to it, and then attach some sort of collision shape to define how that enemy or how that element of the game can damage the player. So that's awesome. That was pretty quick. We're only about 12 minutes into this video. So while we're on the topic of resources, I'm actually going to bring up something. I think I brought it up in an earlier video, but one of the comments in an earlier video was talking about using a resource for all of this information that we're passing into the player right here. And then you can swap out those resources to instantly get different player values and to test different values easily and quickly. And I thought that's a really cool idea, so I want to implement it. And I feel like this video is a good one to do that. It's not going to take very long, and it'll be a lot of fun. So we're going to right click over here in our file system, and we're going to make a new script. But this script isn't going to be attached to any nodes. Okay? We're actually going to call this player, what should we call this script? Player movement data. I guess that's fine. Player movement data. Okay? And we want this script to, we don't want it to inherit from node because we're not going to attach it to any nodes. So we're actually going to make it inherit from resource. Okay? And we'll create that. So we're making our own custom resource. Now resources in Godot, you have scenes and you have nodes. And the third element, and slightly more complicated in my opinion, is resources. Now you've seen resources before. We've used resources before. An icon, for example, this is a stream texture and it's a resource. Okay? You can see that it inherits from resource. So stream texture inherits from resource. So we've used them before. Our player animations, the player skins that we made, these are also resources. You can see they inherit from resource. They're called sprite frames. And there's a lot of different resources inside of Godot, and you can extend those resources as well through scripts. But our script, our player movement data, is only going to extend the base resource script. So we're not going to extend like frames or a texture. We don't need to do that. But we can give it a class name. And this class name will allow us to create resources, because this is just a script that the resources will inherit from. Okay? But we're going to actually be creating resources over here. In the same way that you could right click and do new resource and search for frames like this, and we could create a sprite frames resource. We want to be able to search for our resource, which is player movement data. So class name player movement data. Now resources can contain both variables and logic, so they can have functions inside of them. Ours is only going to contain logic. We're going to click on the player and we can see these variables here that we have set up for the player: jump force, jump release force, max speed. And we want our resource to use those same ones. So let's come back into player. In fact, we'll come into player and we'll actually just copy these. Control C. And we'll come into our player move data and do Control V. Okay. And what are the defaults on these? 160. Let's make this 160. I want them to be the same. -40. So -40. Max speed is 75. And then 5 and 2. So 75. And then the bottom two are 5 and 2. Okay, we've got our resource set up now, and it should have the same whatever values that our player has here. This resource has them as a default. Okay. Now we can right click over here and we can do a new resource, and we'll search for player movement data, and it wants us to create a .tres file, which is the default. TSCN is for a scene and TRES is for a resource. Okay? Just exactly like our player skins here. So we're going to name this one default player movement data. This is our default player movement data, and you can see it's created a new resource over here, and we can edit the properties of this resource right here. Now if we come into our player, we're going to export a resource, and we'll call this var move data. Okay? Unfortunately, Godot does not allow us to export player move data like this, movement data. That would be amazing if we could do that, but we can't. We can only export a default resource, okay? Now we can actually come into our player node, and you can see we now have a move data option here, and we can drag our default player move data right there. Now that we've done that, we can get rid of these other values that we had here. So we can get rid of all these, because we've moved that information into a move data resource that our player is now loading through an export variable. Pretty fancy. Now we're going to need to do move data dot in front of all of our variables. So I'm going to copy this, and then I'm going to paste it in front of any of our variables that we have. And they all are capitalized, so it should be pretty easy to find them. and Godot will warn us if we're missing one somewhere. It will give us a red line. Okay. Now what did we just do? Well, we just moved the data for how the player should move around in the world. And you can see that it works exactly the same. However, we can right click over here. We can do new resource and we can select player movement data. And this one we can call fast player movement data. Now we have default player movement data and fast player movement data. We'll double click on fast player movement data and we'll say, you know, we want our max speed to be 100 and our acceleration to be 15. And while we're at it, let's make it so that the player falls a little bit faster too. The additional fall gravity is going to be 3. Okay, oops. And then Control S to save. So now we have default player movement, which are these values, and fast player movement, which are these values. And if we click on our player, we can drag fast player movement into this here and move around, and now our character moves much faster in the world. See that? And let's make it more extreme. And you can actually edit these values right here. So I can just bring this down and edit these values right here. I don't have to find the resource every time. And we can make it significantly faster just to show for sure that this is working. And whoa, that feels really weird to move this fast. Just incredibly strange. Yeah, that feels awful. I wouldn't use that amount for this type of game. Depending on the platform where you're making, it could feel good. But actually, I like this faster player movement. It feels good. So, really cool system, really awesome. Thanks to the commenter who suggested this, because it can make it really easy to prototype different player movements and test them quickly with other people. You'd be like, try this one, how does it feel? You don't have to go in and edit a bunch of different values every time in order to see. You can have these resources that are different types of player movement. Another thing, actually I just thought of this, but you could have a power-up inside of your game, and what it does is it just replaces your move data with the fast player move data. So if you were to run into that power-up, then you would say something like move data equals load, and then you would just load the fast player move data right here. So this would be in your power up. So like power up function, right? You've got a power up function and it makes your character move faster. And so not only could you use it for testing, but you could use it to power up your player, to give them better stats if they collect a certain item by using those resources. So really cool. Wanted to share that with you. Hopefully you all enjoyed it and learned something from it. Thank you for watching this video, and I will see you all in the next episode.